Hello everyone, my name is Sequiera. I'm a machine learning scientist at ADA Support and an NLP stream owner here at ACE. If you haven't heard of us before, ACE is a global community of machine learning practitioners and researchers who have gathered around topics in AI research, engineering, and product. We host free live sessions like this 3 to 5 times a week and produce premium content in various areas. Today, we have here with us Marco Ribeiro, a senior ML researcher at Microsoft Research, presenting their work on checklist behavioral testing framework for NLP models, which, by the way, won the Best Paper award at ACL this year. Thanks a lot for making time to present, Marco. It's all yours.
Sure. Thanks for having me and inviting me to present. So I'm Marco. As Rio said, I work at Microsoft Research. This is joint work with people from UW, Tongshuang and Carlos, and Samir, who's at the University of California, Irvine. And yeah, it was at ACL this year. Let's get right into it. So the question we're trying to address in this problem is this one. How do I check if my model works? So let's say you're a developer or a scientist or whatever, and you train a model. And let's say that it's a very good model. So you write a paper, like you say, oh, Oscar, my model, I can pre-train this model and it beats all of the baselines on all the standard benchmarks. And it's great. So the question is, should you go ahead and use this model for various applications? Like, should you go ahead and replace your doctor with Oscar if it's better at, I don't know, diagnosis from text data? Or if you work at a company like I do at Microsoft, you have to ask, should I just go ahead and use Oscar in our products? And if you do work at a company, you know that the path from high accuracy to this is useful is not as straight as you would expect. There's many things that can go wrong there. So there's many problems with just measuring accuracy. Models can get really high accuracy using shortcuts, like they can exploit biases in the data set that are not going to be happening in the real world when you actually use the system. They can be susceptible to various attacks. They can lack robustness. There's lots of problems that can go on with accuracy. And you still want to check, like if you have a model that looks good, how do you check if it actually works? So one approach that we've kind of taken as a community is once we come up with a really good model or a model that seems really promising, we write a bunch of papers on it. And I've written some of these papers myself. So you take a model like Oscar and you write another paper analyzing it, saying, this is what happens, this is when it works, this is when it doesn't work, this is some of the vulnerabilities, and so on. And it's great work, it helps advance the field, but it is a lot of work. Like you basically need a team of researchers to go and examine this model. And it just doesn't seem like you're going to be doing this for every model. So in this paper, we're saying instead of doing, not instead, in addition to doing this, how about we test NLP models just like we test software? We have this long culture of testing software using unit tests and so on. There's best practices. Everyone knows that if you write software, you should test it before you run it in production. Why don't we do this with NLP models as well? Like write tests to check if it works. So that's what we're trying to do in this paper, applying insights from software engineering to NLP. And we're calling our process and tool checklist. So when you're testing software, you typically test individual functions or components, or you do integration tests. But you can't really do that with an NLP model because you just have one model, like it's a black box often. And even if it's not, like you can maybe get a gradient. So we're not going to be testing individual functions because we don't have them. What we're going to test instead is linguistic capabilities. So we're testing the behavior of the model and whether it can do certain things. And so we have a list of capabilities. We have 10 capabilities that we think people should test. They're very general, like vocabulary, named entities, negation, and we have a list that apply to a wide variety of tasks. So this is going to become clear that these are specific to the task that you're doing. Like once you have a general capability, it has to apply in a certain way to your task, but it will become clear in a second. Once you know what you're trying to test, a capability, how do you test it? And we're saying, let's test behaviors. Like there's this area in software engineering called black box testing, where you pretend the software is a black box, and here the model is a black box. and you test their behaviors. Like you give it different inputs and you check the outputs. And we are proposing different test types to help people come up with tests. So in the end, what we get is a matrix where the rows are capabilities and the columns are test types. What are the test types? First type, minimum functionality test. This is similar to a unit test in software engineering. So what we're doing is, if we're testing, let's say we're testing sentiment analysis, and we want to test the negation capability. How does negation manifest in sentiment analysis? And if we're writing a minimum functionality test, we will try to write the simplest examples we could come up with. Like it's a minimum functionality. What's the minimum it should be able to do if it handles negation? We'll do
Marco,
stuff like, sorry, go ahead.
Yeah, sorry, we don't see the change in the slides.
Oh, you don't?
Yeah, it's in the first title slide.
Oh, no. So I've been presenting all along.
Yeah,
I wonder what's happening. Let me try sharing my screen instead of just sharing one window. Let me share my entire screen.
Okay.
Let's see if that works. I should have tested the, I'm sorry, I have this drawing the slides and stuff. Okay. Can you see my screen?
Yes, we see checklist now, right?
Okay.
Yeah.
Can you see the slides changing now?
Yes.
Okay. So this is what I was talking about. So you guys didn't see my fancy graphs, but that's fine. I think even with just what I said, it makes sense. But I was talking about having a matrix. So this is the matrix I was talking about. The rows are capabilities and the columns are test types. And I was talking about minimum functionality test, which is the first one. So again, we're doing sentiment analysis and we're trying to test negation. Is it still working? Just checking before I continue.
Yes, it's working now, yes.
Okay, great. So if I'm testing negation, I'm testing the minimum functionality a sentiment analysis model should have. I think what you want to test is examples like this. I didn't love the flight. I don't like the movie. I don't hate this. I don't like this, and so on. Like very simple negations. And once you have a set of those, you can compute, like let's say I have 500 of those, you compute how often does the model fail in this simple sanity checks. That's the first test type, where we're creating examples from scratch. The other two are perturbation tests. So instead of creating examples from scratch, we're taking existing examples and perturbing them, and then expecting something to be the case. And this is, again, borrowing from software engineering, where there's this practice of metamorphic testing, which is basically the same thing. So the first of these is what we're calling an invariance test. And it's very simple. You perturb examples and you expect the prediction to remain the same. So here's an example. If I'm testing the named entities capability, a very reasonable invariance test would be to say, if you change named entities, prediction should not change. So if you have tweets about flights and you change Chicago to Dallas or Brazil to Turkey, that should not change the sentiment of the prediction because it's just location names. Or if you change person names, and very rarely do person names carry sentiment. Like you can think of Hitler, but other than Hitler, typically if you change John to Luke, it doesn't matter for the sentiment. So again, we do this, we take 500 examples and then we measure how often does it fail. And then finally, the last one we call directional expectation test. We're doing the same thing, but instead of expecting invariance, we're expecting something else. And what that something else is really depends, but here's an example for vocabulary. One thing we can do is add very negative sentences to the end of existing examples and saying, look, the sentiment should not become more positive. It can stay the same, but it can't become more positive. So if I add, I hate you, I dread you, you're lame to the end of a tweet, the prediction should not go from negative to positive or negative to neutral or neutral to positive. It can stay the same or become more negative, but it cannot become more positive. So this is an example of a directional expectation. What do you expect once you apply this perturbation? So the process becomes really simple. Once you have this matrix, You as a tester, what you do is you try to fill the matrix. You look, oh, what kind of vocabulary do I expect my model to have? Let me try to write a minimum functionality test. What are invariances that have to do with vocabulary of part of speech? Let me write an invariance test, and so on. You just try to fill the matrix as much as you can. Sometimes it's hard to fill a particular cell, but in general, this really guides the process. And in the end, you get a test suite, and you can check how often does my model pass each of these tests. Now, I said write 500 examples of this particular test. That seems like a lot of work, and it is. So we provide a lot of tooling to help people write tests at scale. So one thing we do is templating plus Roberta suggestions. And what I mean by this is, once you write, this is a good movie, there's no reason why you shouldn't generalize to, this is a good movie, this is an amazing movie, excellent movie. And we're using Roberta to get suggestions of what you should fill the good with. And this helps you really scale and create examples very quickly, easily, and without needing to rely solely on your creativity, because you're getting suggestions. But you're still checking the suggestions. It's not automated. And in the end, you use those to create more tests. So that's one tool. We also have lexicons like person names in different languages. We have location names. We have a bunch of different lexicons that really help create tests, both from scratch and in perturbations. We have a perturbation library where you have stuff like add negation, remove negation, contractions, punctuation, typos. Like we have a bunch of pre-made perturbations. We have visualizations. I just showed one. We have more. Anyway, the point is we have a lot of tooling that make it very easy to create this test. And we have some user studies that show that people actually benefit a lot from this tooling. So you may be thinking, wow, this is so simple. It's obvious that you won't find any bugs. Everyone's already doing this. So let's test some state-of-the-art models. And let's start with sentiment analysis, which is a good domain because there's commercial models available. So it's not only research models, but these big companies, they sell sentiment analysis as a service. So we tested Google's model, Microsoft's model, and Amazon's model, sold as a service through an API. And we also tested research models. So we tested BERT and Roberta trained on the standard data set. And what we're doing here is tweets. Because the commercial models all use Twitter as a use case for what their model should work on. So we did sentiment analysis on Twitter, and we have a data set of airline tweets directed at airlines. So here are some tests. I'm just going to show you a few. There's many more in the paper. So here's an example of testing a capability of temporal awareness of a model for sentiment analysis. And how we do this for an MFT is to measure temporal change. So if you say, I used to hate this, now I like it, that should be positive. I used to like it, now I hate it, should be negative, and so on. We create a lot of examples using templates like these, in this case, 500 examples. And then we measure the error rate. So here we're showing error rate, and it's around 40% for commercial models, 18 for BERT and 11 for Roberta. Pretty high. These are a very simple example, like you'd expect models to handle this well. We tried very simple negations, like negating a negative. This wasn't lousy, this wasn't bad, and so on. And we're expecting the prediction to not be negative. It could be positive or neutral, but it cannot be negative. Failure rate is pretty high, again, especially for commercial models. In particular, Google, like 54% is pretty high. But again, very simple sanity checks. Another example of negation, a little harder, is ending with negation. I thought this would be awful, but it wasn't. I thought I would really enjoy it, but I didn't, and so on. And failure rate here is 100% for Microsoft, Amazon, 90 for Google. Roberta is doing well, but BERT also is doing pretty poorly. So these are just a few examples. There's many more in the paper from different columns. We're also testing Quora question pair, but I'm not showing here. But here I'll show Squad a little bit. And we're testing BERT, which is supposed to have superhuman performance. So this model is supposed to be better than humans at reading paragraphs. So here's some very simple tests. Taxonomy tests, basic properties like antonyms, synonyms. So first example we have there is having a very simple sentence. There is a large pink bat, and then you ask, what size is the bat? And you expect it to be large, and BERT says pink. And then you ask, what color is the bat? You expect it to be pink, and so on. And BERT fails 82% on super simple examples like this. And then antonyms on the bottom. John is more optimistic than Mark, who is more pessimistic. So these are very simple antonyms that you expect BERT to kind of know, but the failure rate is 100%. So we also tested negation for BERT. And again, I'm only showing MFTs because they're easy to show. We have a bunch of other tests in the paper. But here's negation in the context in question. This is very simple paragraphs. Aaron is not a writer. Rebecca is. Who is a writer? Clearly, Rebecca is what's expected, and BERT predicts Aaron or something like it in templates like this 2/3 of the time. And if the negation is in the question, failure rate is 100%. So if you say Aaron is an editor, Mark is an actor, who is not an actor, BERT fails all the time on this kind of stuff. We also did very simple co-reference. If you're going to do reading comprehension, you have to be able to handle co-reference. So we did the simplest one we could think of. A and B are friends. He's a journalist, she's an advisor. BERT just has to resolve the he and she based on male and female names. And again, failure rate is 100% for very simple stuff like this. We also did very simple SRL, which is semantic role labeling. So figuring out who's the agent, who's the object. Like Christian punched Nicole. Who was punched? Like this active to passive. Like who is the agent, who is the object of what's going on? And BERT fails 60% on very simple stuff like this. So clearly humans would not fail at this. This model has serious problems in terms of real machine comprehension. And the point is that these tests really show that, even though accuracy is super high on Squad. So another point is we're using the same process. We're testing the same capabilities. And we did different tests. I only showed you 2 here, but we did more. We tested different models, and we detected bugs in all of them using the same process. So it's not a one-off thing. Like if you use this process, it really is helpful in checking whether these models are working. So there's more tests and tests. There's KQP in the paper. And another point of discussion is that state-of-the-art models still display many bugs that I think were unknown before this paper. Like I didn't see people discussing the fact that these models could not handle simple negation, simple co-reference, and so on. So if you take just a standard benchmark, you can think that model is super smart when in fact there's still a lot of bugs in there. So you may be asking, how hard is it to find these bugs? Maybe it's just that you guys are very good at finding bugs and it's not the process, it's you guys who are spent all of this time investigating these models. So we did 2 things to check against that. One is a case study. So I went to the team at Microsoft who trained the sentiment analysis model we tested that had all of the bugs. And then I said, hey, can you guys do a session with me where you guys are creating tests and trying to test your own model? And this was a model that was very stress tested. Like this was a model that's being used by customers. They have a lot of different test data sets that they use, benchmarks and so on. So we wanted to see, will they find new stuff like we did? And we spent 5 hours with them where they were creating tests. They created about 20 tests, and they found a ton of new bugs. And they found the same bugs we found. They found new bugs we didn't find. In some, even for a model that had been extensively tested, using checklists, people found a lot of new bugs. And the second thing we did was a user study. So we have a lot of different PhD students or people at Microsoft testing a model that they had not seen before. So these people are not experts on this particular model. So they're testing BERT on KQP, and we're asking them to test it for 2 hours. And we have 3 conditions. One is unaided, where we just say, test this model, do whatever you want. Here's a Jupyter notebook. The other 2 are subsets of checklists. So one, we're telling them, here are capabilities, try to test these particular capabilities. And the other one, we're telling them what capabilities they should test, and we're giving them tooling, like the templates and so on. So what were we measuring? We're measuring how many tests they came up with, and they came up with, in the same amount of time, many more tests when they used checklists. We also measured how many test cases they had, because a test, you can have a bunch of test cases. And if you don't have tooling, if you have to write tests by hand, you end up with 5, 7 test cases. When you have tooling, you end up with 200, which is much more robust. And then we measure how many bugs they found, and this is self-reported. Whatever they found, they said, this is a bug of this severity and so on. And they found 3 times almost as many bugs with checklists than without. So they found, with checklists, more tests, more coverage, more bugs, and they found the same bugs we did. They found other bugs. Really, they found a lot of bugs on this model that people in the community hadn't found. People who are publishing papers on KQP hadn't found. So this is encouraging because it means that basically anyone or almost anyone using this process can come up with tests that are helpful in finding this stuff. So just finishing up here, summarizing, the message here, if you get one thing, is we should test NLP models. Let's not just rely on accuracy. Accuracy is important, but we should go a step beyond accuracy, hence the title of the paper. And also test NLP models, just like their software. And we're saying, look, let's borrow all of these insights. We have this culture of, I didn't really get into how we're borrowing the insights in the paper. We go more into that. But we have all of these insights from software engineering. Let's just apply them to NLP. So we're telling people, what do you test? This is guidance that people get. Here are capabilities for you to test. This is how you test, different test types. Here's tooling for you to test, visualizations, fill-ins, lexicons, and so on. So there's a whole package to help people test. And you can try it out. It's open source. I already have a bunch of positive feedback from people who have tried to use it. I'm maintaining it, adding new features. And also check out the paper, because there's much more that I didn't cover in there. And that's all I got. Thanks.
Thanks a lot, Marco. Great presentation and great paper. Congratulations on your ACL Best Paper Award win. It definitely well deserved. And it was mentioned to you earlier, when I was reading the paper, I chuckled at a few places, like, for example, BERT is claimed to perform, in par with human level reading comprehension performance, but you do show that, like, even in the presentation, you mentioned that as like some really simple cases where it fails. Very interesting. Something that I'm interested in knowing is, how did you come up with, like, what's the story behind the project or the research paper? Was there a need, or were you like curious about how NLP models? Did you want to check them before you deploy them? Like, what was the story behind the project?
So during my PhD and after, like, I've been focusing quite a bit on understanding what models are doing. Like, I have a few papers on explanations. I had a paper on ACL a few years back on adversarial examples that were one kind of bug, like a robustness kind of bug. And at that time, like, this was a couple of years ago, I thought, I could turn this into unit tests. Like, this, it was semantically equivalent rules. So I'm saying, like, if you change what is to what's, it shouldn't change predictions. So I had these invariance tests already. I didn't call them that at the time. But I thought, I could turn this into unit tests. Like, why wouldn't we just have a suite where we always check models if they succeed in this? But then I realized, oh, this is more general than that. Like, it's not just invariance. Like, there's all this other, why don't we just do this? Just like, why don't we write unit tests? And that's how I started going about it. And then in the process, figure out, hey, we should probably give people guidance into what to test. Like, started reading the software engineering literature and trying to apply what I was reading there into NLP. Obviously, it's not a direct application. There had to be some creativity there.
Yeah,
that's the story.
Definitely. I think, and I was mentioning this to you earlier too, I've been using the toolkit in my current project at our work too. And like you mentioned, I thought, oh, this is like, is this actually gonna surface issues? But, we have actually figured out some vulnerabilities quite a bit in across certain capabilities. And I think, and I would encourage all our viewers to check it out, because it's so simple to use. You can also you like search failed test cases and things like that. It's just running a simple Jupyter notebook, and I think very user friendly as well. I think there were some other questions from our viewers. There's a question from Navsheen Fatma. While filling blanks from pre-trained model like Roberta, how do you know if it's a positive sentiment word or negative, good versus bad?
Right, that's a great question. And that's why we're not just filling blanks automatically. Like what Roberta is giving you in that case, it's giving you a list and you check the ones that are positive. So I'm assuming that the human creating the test knows what they're looking for. So if you're testing sentiment, for example, you do this once and you create a list of positive adjectives. And then you do it once again and create a list of positive verbs like love, love, enjoy, and so on. Then you do it once and create a list of negative ones. And you use that throughout your tests. Sometimes you can use it without checking. Like if you're replacing, like if you're doing an invariance test and you're replacing the with a, like you can just let Bert fill in or Roberta fill in and it's not going to do anything weird there. But if you're creating MFTs like that, you have the human checking what's going on. You're not just using Roberta blindly.
So Abhilash had a bunch of questions. I'm going to read the second one here. He wants to know, what do you mean by bugs here? Very simple false predictions or some sort of fallacy in the loss function or something else. Like, how do you determine what a bug is?
Yeah, that's a question we get a lot. I guess we picked the term bug because we're seeing the system as a whole. Like I'm not thinking of loss function. I'm thinking this is a black box that's supposed to do a task,
Mm-hmm.
predict sentiment. So I
Mm-hmm.
expect certain behaviors of a sentiment predictor. I don't care about the internals, but I expect certain behaviors. And
Mm-hmm.
bugs are this when this behavior expectations are not met. That's what I mean by bug. I expect models to be able to handle simple examples. That's a
Mm-hmm.
bug when they can't. So it's not the same thing as like accuracy where you're saying it has to be higher than 90%. It's just, it should work on this stuff. And
Right.
if it doesn't, it's a bug. It's a behavioral bug. It's not obviously a software bug like in the where you implement something wrong.
Yeah.
So I'm not sure if that was a good choice because I do get this question quite a bit, but I do like thinking of them as bugs because it is a bug if you're trying to use this in the real world.
I would agree too. There's another question, very interesting actually. What about tasks like machine translation, abstractive summarization, so on, right? There's so many evaluation metrics for these. How do you know what to use, or there be like how can you even come up with unit tests here for
Yeah.
cases that involve generation?
So in those cases is where I think that this is perhaps even more important because the metrics that we have, everyone in the community agrees that are problematic. Like even if you have high blue scores, there's still problems.
Mm-hmm.
So more than even in the cases I showed, like you want to check specific behaviors. So what ends up happening is in that case, it's the same problem that the metrics have. You usually don't have one specific output that you're checking because
Mm-hmm.
there's many possible good translations. What you end up testing is properties. So you
Mm-hmm.
end up saying things like, if there's this proper name in the input, this proper name should also be in the output. Like you're not saying the output has to be this, you're saying the output has to contain this word, or the output cannot contain this word, or the output cannot be 3 times the length of the input.
Mm-hmm.
Or if I have this input and do this perturbation, the output should change in this particular way. You're not specifying necessarily what it should be, but you're specifying properties. And it's
Mm-hmm.
a little harder to come up with, but I think it is possible. And as I said, because the metrics are not as trustworthy, you want to do this kind of testing.
Mm-hmm, mm-hmm. So your recommendation is more like use it as a toolkit to figure out more failed test cases and not just use it as it's not a silver bullet, right? Like you just use it as like in addition to other metrics.
Oh yeah, for sure. Like checklist is not meant to replace accuracy or metrics or other evaluation techniques. It's meant to augment them. Like
Mm-hmm,
this is a question that I get quite a bit as well. You didn't ask it, but I'll say, even
mm-hmm,
if you pass all of the tests, that doesn't mean that your model works. It's
mm-hmm.
just like in software engineering. Like you can write a bunch of unit tests. You get more information when they fail than when they succeed. When
Right.
they succeed, it may be that the test is not broad enough, or it may be that it's actually working.
Mm-hmm,
You get a little bit more confidence. At least it passes the test. It's probably at least not terrible,
mm-hmm.
but you can't say it's working. And
Right.
that's where other complementary evaluation techniques come in.
Right.
So you get more and more confidence. Hey, my accuracy is high. I'm passing all of these tests. I ran this other check and it's also working. I can probably trust this model. But if it's failing very simple unit tests, then you can say, okay, I have to go fix this.
Mm-hmm. Something that I really like about the paper is the invariance and directional expectation test because you don't really have to have labeled data for these, right? Like you just
Yeah.
think of the behavior. And one question that earlier when we were discussing with the community that came up was, what are your thoughts on adversarial attack frameworks such as text attack? Are these covered by the invariance test on checklist?
Yeah, it depends on what the attack is. I'm not super familiar with text attack, but
Mhm.
in general, adversarial examples would fall into the invariance test type and typically under the robustness capability. Like, but yeah, it's again, adversarial attacks are helpful, and this kind of is a way of organizing them. Where would they fall under my whole testing suite? And typically, they are invariance tests.
I see. Okay.
So
And
one big difference though, sorry, let me
yeah,
just compliment. One big
yeah.
difference is typically adversarial attacks in general are not model agnostic. So if you're using gradients or something like that, it's harder to get a set of test cases that you can apply to a variety of different models to compare between them.
Mhm.
Because what's going to be an attack for one model is not necessarily going to be the same for another model.
Right.
So we're trying to be model agnostic here. So
Mhm.
that's, I guess, another kind of difference.
Yeah. The other question is I think you sort of mentioned this in the paper too, and some of our viewers were also interested. That language models essentially, I mean, recently have known to be, biased, or like do all these bias predictions. Maybe. What about, like, how can you apply checklists to test language model biases or fairness?
Right. And when you say language model, you're thinking like GPT, like something that's generating language. What are
Right.
you thinking?
More
Yeah.
like
Okay.
let's say language generation, or like
Language
generation.
generation. Yeah, this is something that I'm actually working on right now, testing natural language generation. But
Mm-hmm.
in general, my answer to this question, like how would you apply checklist to X? I have two answers.
Mm-hmm.
One is top down. Just look at the matrix. And if you're thinking specifically of fairness,
Mm-hmm.
the way I'll do it is let me pick a few groups that I care about and think what kind of behaviors are acceptable or not acceptable.
Mm-hmm.
So when I think of groups, like I think religion, race, gender. So let's take religion for example. How would I test a language model? Initial template that comes to mind. John is a Christian and is also a, and then complete. And then change Christian to Muslim, and then change Muslim to Hindu, and see if I have a list of positive things and a list of negative things, my expectation is when you change religions, it shouldn't really change that much. So
Right.
if the model is saying like John is a Muslim and also a terrorist, that's way higher than a Christian and also a terrorist, that's a
Mm-hmm.
problem.
Right.
So that's one. Like I'll try to think of more of those examples, and again also change the groups, like
Mm-hmm.
change John to Mary and see what comes up and so on. So
Mm-hmm.
this is a top-down approach. Like you just try to think of what the problem is and come up with different examples.
Mm-hmm.
The other approach is the bottom-up approach. So I look at a few examples in the wild, like I try to get a few examples from previous press release fails and so on of unfair behavior.
Mm-hmm.
But I don't stop there. I try to generalize them. So
Mm-hmm.
I look at a few examples and say, what is the underlying behavior here? Like what is going on here that I can generalize into a test?
Mm-hmm.
And this is very fruitful as well. Like you can get an idea. It's usually the case that you can generalize.
Mm-hmm.
So I don't have a whole test suite, but that's the process that I would follow. Top
Mm-hmm.
down, bottom up.
That's very insightful. Thank you for that. The chat is actually blowing up with questions. Let's see. If we think about these kinds of tests as being unit tests for ML models, what significant difference do you see between traditional software unit tests and these?
Yeah, one big difference that I mentioned is that you don't have access to the code, and also once you find a bug, it's not as simple to go and fix it.
Mm-hmm.
And one more thing is that typically in software engineering, the behavior is deterministic. You're saying this should be that, where here we kind of accept small failure rates. So for example, if I change people's names and it changes 0.1% of predictions, then I don't really care. If it changes 20%, maybe I do care. So there's a tolerance level that kind of depends. Like if it's racist on 1% of cases, maybe I do care quite a bit. Like the tolerance threshold depends on the application, depends on what the test is. So those are two immediate differences. And the other difference is that here, again, we're testing capabilities. This is it's NLP specific, what we're testing. Like we're testing, does the behavior work in NLP?
Mm-hmm.
Yeah, there's more differences as well, but I think those are a good start.
The other question I had, and one of our viewers also asked is checklist complete? Are there some limitations that the checklist may not cover, for example, or do you think you can use it for, all kinds of behavior testing, maybe?
I think it's not, as I said, it's not a silver bullet. Like it's not going to solve evaluation.
Mm-hmm.
But it's very hard to think of any NLP test where you wouldn't benefit from testing simple examples of input and output, or that
Mm-hmm.
would be a detriment, like, or that would be bad. So I
Mm-hmm.
think it's really general and it's really useful. I can think of tasks where parts of checklists are not as helpful. So for
Mm-hmm.
example, we're talking about the perturbation tests.
Mm-hmm.
Maybe for some cases, it's very hard to come up with them. Like if you have very long documents
Mm-hmm.
on some tasks, it's hard to think of perturbations and expected behaviors on those long documents. So that part of checklist is not going to be as applicable. But in
Mm-hmm.
general, like this idea of let's check simple things, I think applies really broadly.
Mm-hmm. The other question I had for my own work in some ways, do you recommend weighting the capabilities? Like when there are failure rates for individual capabilities, do you recommend like weighting depending on what your case is? Like for you, it might be important that certain capabilities pass more, like have lesser failure rates than the others.
Yeah, for sure. Like and the capabilities, we try to do them in increasing order of kind of abstraction, so it becomes more and more difficult.
Mm-hmm.
So typically, like if you're failing vocabulary tests, you're also going to be failing negation tests because they're going to be depending on that vocabulary.
Mm-hmm.
Um, so I would be more concerned if you're failing vocabulary and negation.
Mm-hmm.
And even the examples I was showing before of sentiment analysis, I really care if my model cannot get this is not a good movie right. Like it should be able to get that. If
Mm-hmm.
I have some more complicated test, maybe I'm like, okay, it doesn't pass, but I kind of understand it's okay. So it's not necessarily a weighing of capabilities. It may be, but it's also a weighing of specific tests. And typically when I'm writing tests, I'll write tests at varying levels of complexity. Some are not simple sanity checks, like can the model do this impressive thing? And if it fails, I get information, but maybe I don't discard the model all the way. Whereas
Mm-hmm.
some tests, obviously, if it fails, it can't go into production. It's racist. Like it's going to put me in the news. I'm not going to put this into production. But the weighing is very task specific, application specific. Like if you're a researcher versus if you're Microsoft, you care more or less about whether your model is racist. If you're Microsoft, you care a lot. Like if you're a researcher, maybe you write a section in your paper saying, "Oh, look, it's unfair. We should try to fix that."
Mm-hmm. Uh, the other question I had is this is more of a clarification question. I think in the paper you say that the BERT was like the BERT model was fine tuned on like binary labels for sentiment analysis, but when it is compared with commercial engines, they are non-binary labels. Why wasn't BERT fine tuned for like you know?
Right. Yeah, the reason is we needed a data set with negative, positive, and neutral examples, and I didn't have a large data set. Like I did have the data set that I was using to test, but I didn't want to train and test on the same data set.
Mm-hmm.
And SST is a pretty standard data set for sentiment analysis, so I thought it would be good to use as a baseline. I actually
Mm-hmm.
did not expect Bert or Roberta to outperform commercial models. I thought, oh, this is going to be a baseline. But
Mm-hmm.
Roberta was actually better, even though it was trained on binary labels. It was better across the board, better
Yeah,
than everything, basically. So that was kind of surprising.
yeah.
Um,
I think that's sort of the questions we have from the viewers and from me. The last question I had is, what is the sneak peek into the future work looking like? What are some of the next steps that you're considering?
Yeah, there's a lot research-wise. I don't know yet, but given what we already have, we've been working on testing new applications. So I mentioned I've been testing or working on testing natural language understanding. Sorry,
Mm-hmm.
not generation, natural language generation. So to see, it's pretty broad. Like we already applied it to 3 tasks, and I did one more that I didn't put in the paper. But we're applying it to even more tasks and trying to come up with different checklists. Um, I also have been working on making it multilingual, so it already has some functionality for writing tests in different languages. And I'm working with some folks at Google on trying to come up with multilingual checklists. So if you have models that work in different languages, does this generalize to different languages? And I think it does, but it's good to check and have that uh, as examples.
Mm-hmm.
And I'm also like kind of working on new features and better software. Like I'm trying to integrate this with I have a pull request on Hugging Face's NLP to make it even easier to run checklists. Like if you're already using Hugging Face transformers and stuff, it should be very easy to use. So integrations like that, I'm probably also going to do on NLP. So nitty gritty stuff like that, I'm still working on that. But research-wise, I guess one big direction I do know is fixing the problems once you find them. So that's an area that I'm actively working on.
Mm-hmm.
Checklist gives you a diagnosis, but it doesn't give you a cure.
Mm-hmm.
It says here are a bunch of problems, and sometimes once you see the problem, you can imagine a fix, but sometimes it's not as simple. So trying to figure out how can we go about systematically fixing these problems. It's, I think, a good research area that I'm working on.
Wow, that's really exciting. And like I said, when I first tried checklist too, just with like 3 lines of code, you could generate thousands of test cases. It's really amazing work, both in terms of think this is a real user feedback, and also in terms of research and things. So thanks a lot for agreeing to present and for the great presentation, Marco. Thank you so much.
Thanks, really appreciate it.
All right. Thank you so